I talk about the machine learning development cycle and what is going to happen, who going to involve, and what is the problem of developing model from data exploration to prototyping and model production. Um, that is the user scenario part. But now let's look at what exactly um, a machine learning system looks like. So this is an extremely oversimplified architecture of a deep learning system. Inside the gray box, we have different components. We have each service, for example, data management, dataset manager, which is manage the dataset for training. We have model trainer, which is a training service, who has a lot of computing resources to executing model training. And we also have a model serving service, which is hosting customer models and to answer model inference. On top of all this, we have a metadata store and artifactory store to store and manage the metrics for training and serving. The whole purpose of this is for the reproducibility and tracking purpose. The whole reason is like when we see a model problem, when we see performance regression happens, the first thing we do is check out the model metadata of this model, like who produced this model, what data set, what is the version of the training code, when that happens. That will be great to simplify the model troubleshooting. It will make it a lot easier. On top of that, we have a workflow manager, which is automating the transition between all these components. So you can define workflow. For example, first, after the data after we receive data to build a new data set, we're going to trigger training. After training comes, we're going to trigger moving the model to serving. That is, you can consider is a training pipeline. We can use workflow as well to write a data processing pipeline as well. The last part is a notebooking service. It could be other service. The idea is to build a data exploration or prototyping environment for data scientists to explore the data, and also you leverage the computing power provided inside the system to build their models as well. So the whole entire complicated system is exported by a set of public API, and people can access all the functionalities through a UI or through notebooks or through a web API service. So as you see, the purpose of such a complicated system, we have two main purposes here. One is the goal is to automate the model development process as much as it can. Second is we want to empower data scientists to take the driver's seat of model development. So we're hoping like by exposing some UI, by exposing some public API, data scientists are able to leverage the entire distributed system to complete his work. He doesn't need to have cross collaboration. He doesn't need to understand the complexity of the learning system. They just click a few buttons and get things done. I have just explained a little bit. The main benefit of the machine learning system is reduce the complexity by hiding providing the automation, by hiding the complexities behind the UI and easier API. We don't need all the different roles to collaborate during model development. And also, the cross-functional collaboration will get reduced dramatically. The reason is now the information of a model training of a data is stored in a centralized place by the system. So everybody can just use the UI to access the information. We don't need to ask anyone to manually to do anything. Because we automated the whole data processing, building, deployment, and we also automate the model troubleshooting and monitoring, the whole velocity of the development cycle get improved quite a lot. That's the benefit and why we invest heavily in the machine learning system in every company. Trend, it's how the deep learning system will evolve. I don't want to talk about technology because technology always change. We always, for example, today we may use Argo flow to drive workflow. Tomorrow maybe use some other flow. But the one thing it will be not change at all in the next 10 years, in my opinion, it is human focus. So a good ML system is designed for data scientists to improve the model development cycle. It's to improve the velocity of model development. Ideally, it can encapsulate all the complexity, like here. Overall, it's already a oversimplified architecture, but still not very inviting. A good system can encapsulate them all and only produce simplified options for data scientists to complete their work. So you don't need to be expert like DevOps, expert on data processing, or expert on distributed computing, but it still can finish its job. Like I need to get some data, I need to trigger training to run my training code, I need to see the model in production. These are the basic things. It should be simple for data scientists. And I believe most of the system going this computation way, on one side, it's going to become more and more complicated. On another side, it will become easier and easier to use from data scientist perspective. So this is the trend. We as a deep learning system engineer should absorb the complexity, handle this complexity, but offer simplicity to data scientists. One good example is the car, right? The car gets more and more complicated, but the driving a car is actually, compared to that, is extremely simple. This is the last key point I want to mention for the machine learning system introduction is building model and building machine learning system are entirely different things. Building models is we write model training algorithm to produce a model, and that's it. But building machine learning system is to build the infrastructure that supports model development. One specific example is I can write my training algorithm in TensorFlow or in PyTorch, but I cannot execute it in my local because in production, all the computation happens in a remote computer automatically. We develop a training service to execute the model training algorithm code in a server cluster. That is the relationship between building a service and building a model. So that's why at the introduction phase I mentioned there are two parts of the AI field. One is model development. Another is the underlying infrastructure that supports model development, which is the latter. That's why we choose to build machine learning systems. For any complicated concept, the most applicable way to understand it is to look at the example. In this book, we talk about deep learning systems. So naturally, we build a extremely simple but functioning deep learning systems. In this small deep learning system, we have like 4 different components and 1 storage. I will give a quick demo after this slides. But before that, I want to give some introduction so you understand what are we talking about in the demo. So first of all, we have a dataset management service, which is we can host the datasets. And also we have a model training service, which people can just submit the training request. And this service will find the computer results to execute the training. After it completes, it will save the model somewhere and also upload the metadata to a storage. Now I'm a application developer, right? I need to query a web service we call prediction service to get the model inference. To an example, let's use the chatbot as an example. We want to have an intent classification feature for this chatbot. So first of all, as a data engineer, I upload a bunch of training data to training service. Then as a data scientist, I write my training code by consuming, I want to kick off model training. Then this model training service will find the data in the data management service and execute the model training and produce a model and save it into Metastore. And then the chatbot application will send web requests with a body of text message and asking for the prediction service, hey, let's use the model you just trained, the intent classification model you just trained, and give me the classification result, model inference result. Just tell me what does customer think about this conversation message. As you can see, we only have like 4 or 5 small services, but to set up all the networking, it is still very intimidating. As a result, so we build a shell scripts. We change everything into Docker image, so making sure it can execute easily on our local. In this book, actually, we have each section. For example, chapter 4, we have data management service. We have a demo script just for about how to execute play with the DM. But in this demo, we just look at the lab. The advantage for the lab is it will start all the service together, so you can experience end-to-end yourself. One thing I need to apologize is right before the demo, I was updating some script, breaks a little bit scenario at the end, but most of them still are executable. But let's see how it works. So I already downloaded the source code. So let's try to start the script. From the lab scripts, we first start all the services. It will be easier because I already pulled the image from the code-wise. You can see we downloading all the Docker images and set up the network, making sure all the components can talk to each other, and starting different predictor trainer and all that. Let's try to run the second script, which is to upload the dataset. It will try to. I think we have some issue on the backend mini IO product, which is I saw it happens 5 minutes ago. Now it's actually affecting the previous one. I need to figure out what is wrong. But I can give a quick description about the demo script. First of all, what it's trying to do is it's downloading the tweet dataset from Hugging Face, and that's a little bit process. After that, you will see the whole dataset gets created. And in each dataset, this is another complete concept about dataset we will talk about in chapter 4, but I will just give a really quick high-level description is we need to have a dataset ID to uniquely identify the dataset. But because we can keep updating the data, right? That's why we have different commits. So during the model training, we need to remember we recorded exactly what data are used in each training iteration, each training attempt or each training run. From that perspective, we need to remember a hash code about the training, the data binary, a snapshot are used in the training. This is a little bit complicated, but I really encourage you, if you really want to understand the dataset, it's better to read chapter 4. After you have a dataset ready, you can kick off training by provide the dataset ID. So what it does is it will tells you, hey, I'm gonna start a model training run, and I will use dataset equal to 1, and also I'm gonna use the this version of the dataset snapshot. So the purpose of this is when next time when you update the dataset, but you can still use the old data to reproduce the model produced in the past. That's for the model reproducibility. So after the model training completes, and you can use the model serving script. You can provide a model ID, and you can give a content. Use the example here, say, because after model training completes, the model will automatically copy to the training service and also copy to the metadata store. So we can just trigger a model prediction with the newly produced model. We can see this is the model ID, which identified to the model we just built. And the payload say hello world. Just give me the intent message about this. And they give a result, right? Say hello world means joy. Yeah, and then another script here, which is doing the similar thing but more advanced. We can tell you, say I can update the data set with more data, so you can retrain. This is a quiz we produce for the training lab. Unfortunately, I break my local environment today. Right now, I think it feels that although we didn't see it running on my local, but I hope you can still see how a deep learning system can actually facilitate the model development just by having these very simple components and link together. Then you can use a few just training scripts to kick off model without managing the computing resource, without managing the metadata. You can without manually copy the model. You get all the versioning support, all the automation behind, and reproducibility together with this service. We will talk about the design principle for each component in the book. I highly recommend you to look at these principles. In the last section of this presentation, I want to give some suggestions of how to transition to machine learning systems, or building machine learning systems. One big problem I see when working with experienced developer on building machine learning system is we tend to think model is a static file. We tend to build a generic distributed system to apply to machine learning scenario. That is a pitfall for experienced developer. Let me explain why it is. So normally, before deep learning system, I think most of the platform are data processing platform. They are like data processing, data streaming, and data platform. That is the all computation, right? That is for example, for search, for Bing, for Google, they all have this large data processing platform and distributed system for model caching, for content delivery. And the common part for this system is it is very generic, and the content they deliver and passing over are static. And now we normally want to carry the thinking into the deep learning when building deep learning system, but model is not static. It's very confusing. Is model is a file, right? We often say, "Give me the model file," but model file is a binary, but it essentially is a program. It's algorithms. When we use this model file, it's not a data I just read it as a static. We actually host the model as a program and we execute it. That is the main difference between deep learning use case and the traditional data platform. This means the model always changing. The model performance always changing. We deliver a program from the system and not we deliver a static binary. From that perspective, first of all, we need to modify our computation to in favor of deep learning or machine learning requirements. This is one. Second is the post-model monitoring are a lot different. The metric system is a lot different. The old way is metric system is to visualize what's happening inside the system, look at what's went wrong. For deep learning system is the metric. We still need to do that from the system healthy perspective, but also we should focus on model reproducibility. We need to capture everything involved in the model producing process in order to reproduce it. This is extremely critical for performance troubleshooting because model is essentially learned from the data, and your data can get stale because customer behavior changes. You have always need to update the model, but in that case, if you don't have a way to reproduce it, it's going to be very hard to when you have a model regression issue, when you're troubleshooting a model regression issue. That's why we need to keep in mind model is not static. Second is a ML system. It is a distributed system, but we need to specifically tailor it for machine learning use case. As I mentioned, I need to extend the system to catering, for example, federal training, for distributed training, for hyperparameter optimization. Those are all distributed computing, but this requires a specific setting for machine learning, for the framework we use. This is different than the generic way of just hosting the container. For machine learning case, we really need to understand how this training algorithm are executed in order to make it faster. The last one, and actually it is the most important one, which is human-centric. When we build, for example, data platform, when we build distributed system, we actually design a system from machine to machine, right? We receive some data from for example, upstream system, and we produce data, will displace or will pass over to downstream system. It's an API to API base. It's a programmer to programmer. But in the distributed system for machine learning system, we're design and build the whole thing for data scientists. Just please remember, also remind yourself, you're building the system for human to use. In a lot of time, I see the opposite ways. We build a system for machine to use and ask a data scientist to pretend to be a machine to use the system. Therefore, it is super hard to use. As a result, the model development velocity is very, very slow, and basically data scientist cannot do anything with this system. So usability is the key. What is the path to machine learning system engineering? To build a good system, machine learning system, we just require three parts of knowledge. One is web service programming. We need to understand distributed computing. We need to understand microservice architecture. We need to understand the cloud, because right now for machine learning and deep learning, we require a lot of computing resource, right? Most likely the cloud or the Kubernetes managed cluster can provide us the freedom to create the sudden requirement for a bunch of computation. That's why you need to have really good understanding about the infrastructure you can leverage. This is one. Second is we need to have a little bit basic knowledge. As I mentioned, we often get intimidated by the deep learning algorithm and the math theory behind. But the truth is, as of today, the training algorithm, although they can be super complicated, the model architecture can be super complicated, the training time can be very long, but they all share the same pattern. For example, they all run a neural network, the training through iterations. So if you just learn very basic ones, you learn how the neural network works, what is the training epoch, why people need the metrics, what is the loss functions, what has a optimization method. Those are very common and generic and not very difficult to understand. Once you know it, you have an idea about, okay, where I can optimize the deep learning system and to facilitate or to improve the training velocity. Again, this is not difficult at all. I learned a hard truth from this. I spent 1.5 years to learn the deep learning algorithm. And then I realized actually maybe just take a few months to take some Coursera course, you should be good to go. Now another one is the foundation of machine learning system. Yes, it's also the SageMaker and I mean the AWS machine learning system, and also Qflow, the open source one, open source by Google. They are very complicated and confusing. But if you look down to the bottom, they are shared components. Like they have model training service, they have trainer, they have model serving components. And if you just look at this training and model serving, this basic fundamental functionality, if you understand that, the system is not complicated to you. So as I mentioned, like to understand a complex system, we always go to fundamental, find the basic ones. This is why in this book we decide to build the model training service, build a model serving service with maybe just like few thousand lines of code. So once you see it, the whole big system is very easy to digest. The last one is, okay, if you want to design for data scientists, if you want to build a human-centric and user-friendly deep learning system, we need to understand machine learning project development process. So that is our data scientist, our customer. We build a machine learning system to facilitate model development process. So we need to understand the user requirements. Therefore, you can drive and improve the systems. I guess that's all. It's not completely difficult at all, in my opinion. If you are a developer already, and you already have number one, right? And then you take a few months to understand machine learning, and I guess you're good to go. And if you can find our book and take a look at all these basic components, you should have a good understanding of ML system foundation. Therefore, I think this is not an intimidating task. If you want to join this vividly growing IT field, it should be feasible. At the end, I want to recommend two books. First is the Engineering Deep Learning System, which is I co-author with Donald, my friend. This book is, as I said, it's try to explain the basic foundation of deep learning system. You learn the principles, you see the example for the basic services. You should know, okay, how do I research for the open source one? How do I understand the open source project? How do I optimize the system I had in the workplace? Another one I want to recommend is the Machine Learning Engineering in Action. This is written by Ben Wilson from Databricks. This book actually gives you a very good explanation of how the machine learning project development from a data scientist perspective. This is what I mentioned from learn the machine learning project development process. If you want to drive a future growth or the future direction of a machine learning system in your organization, it is highly recommended you to learn what is the process from a data scientist perspective on driving, because we build a system to make them success so we can success. If you feel interested about this book, you can search on this book.